Hey guys, so in this video we are going to discuss curvilinear motion of particles using rectangular coordinates. So curvilinear motion occurs when a particle is moving along a curved path. Since this path is often described in 2 or 3 dimensions, vector analysis will be useful to formulate the particle's position, velocity, and acceleration. Okay? So let's say we have a particle here moving in a curved path. And then let's say it is moving in 2 dimensions. So along x and the y direction. So ngayon sabihin natin na this particle is accelerating. Ibig sabihin, magkakaroon siya ng components of acceleration along the x and y direction. So let's say that the acceleration along the x direction is a function of vx, x, and t. And then yung acceleration naman natin along the y direction is a function of vy, y, and t. So kung mapapansin nyo, yung acceleration natin along the x direction only depends on the velocity and the displacement along the x direction lang din. And then similarly, doon sa y, yung acceleration natin depends on the velocity and displacement along the y direction lang din. Okay, so let's say that this particle is moving in a 3-dimensional space. Ibig sabihin, magkakaroon pa siya ng component of acceleration along the z direction. And then, similarly, yung acceleration natin along the z direction is only a function of velocity and displacement along the z direction also. So, these equations are said to be uncoupled, because the acceleration in any one direction is independent of the motion in the other 2 directions. Okay? So, wala siyang pakialam doon sa dalawang other directions. So, if this is the case of our curvilinear motion, so we can represent this as a superposition of independent rectilinear motions. So, ano bang ibig sabihin nun ng superposition? Ibig sabihin nun, we can view the motions in the x, y, and z directions as independent rectilinear motions that can be analyzed separately with the tools that we have discussed in our previous videos. So for this example, since our particle moves in a 3-dimensional space, yung motion niya can be analyzed by treating it as a superposition of 3 rectilinear motions. Ibig sabihin, titingnan natin yung motion ng particle natin along the x direction only. So, parang rectilinear lang siya along the x direction. And then, i-analyze din natin yung motion niya along the y direction. And iti-treat natin siya na parang rectilinear motion lang din along the y direction. Pagdating sa z direction, same lang din yung gagawin natin. Again, this can only be applied if our equations are uncoupled. Ibig sabihin, pwede natin silang i-analyze separately kasi yung motion natin in one direction is not affected or dependent doon sa motion ng dalawang other directions. So, in short, although our particle is undergoing curvilinear motion, pwede natin siyang i-analyze na parang rectilinear motion lang din along the x, y, and z directions. Okay, so now let's take a look at some sample problems para mas maintindihan natin itong concept na to. So for our first example here, as the 1,200 kilogram car travels over the crest of a hill, its position is given by, okay, so merong given na equations for the position of our car along the x and then y direction. So for the additional given, we have v sub o equal to 30 meters per second, h equal to 10 meters, b equal to 50 meters, and t is the time measured in seconds. So determine the contact force between the car and the road at point A. So as we can see, as our car is moving over this hill, yung motion niya is curvilinear kasi naka-curve yung path niya. Pero take note na yung binigay na functions of the position of our car along the x and then the y direction is uncoupled. Okay? So along the x direction, we have v sub o times t. So v sub o natin, that is a constant na given. It does not depend on the motion along the y direction. And then similarly, yung position ng car natin along the y direction does not depend on the motion along the x direction. So therefore, these two equations are uncoupled. They are independent of each other. So although the path of the car along the hill is curved, we can still analyze its motion in the x and y direction as independent rectilinear motions. Okay? So in this case, we will use rectangular coordinates kasi rectangular coordinates din naman yung given sa atin, x and y coordinates. So if you encounter these types of problems, okay, so although curvilinear siya, curved yung path, pero yung binigay naman or yung given is rectangular coordinates, then I suggest that you analyze it using rectangular coordinates. Again, yung hinahanap natin dito is yung contact force between the car and the road at A. Force yung unknown. So from the equation of motion, in order to determine the value of our force, kailangan natin yung acceleration ng car natin at point A. So again, analyzing the motion of our car here. So first, along the x direction, we are given the position of our car at any time t, so that is equal to v sub o times t. So to get the velocity, we will simply take the derivative of this with respect to time. So our velocity along the x direction will be equal to VO. Now to get the acceleration, we will simply take the derivative of our velocity along x with respect to time. But take note na yung value ng velocity natin along x, which is equal to v sub o, is equal to 30 meters per second. So that is a constant number. Ibig sabihin, yung derivative nito, derivative ng isang constant number, will be equal to 0. Therefore, yung acceleration natin along x is equal to 0. Okay, so next naman, we will analyze the motion of our car along the y direction. So from the given position of our car along the y direction, we will simply take the derivative of this with respect to time in order to get our velocity along the y direction. So now we have this equation for the velocity along the y direction. Next thing that we will do is, again, we will take the derivative of this with respect to time in order to get our acceleration along the y direction. Okay, so ito na ngayon yung acceleration natin along the y direction. So as you can see, this is a very short equation. Okay, so wala lang, no? Napakaikli ng equation ng acceleration natin along the y direction. Again, recall that we need to obtain the contact force at point A. Ibig sabihin, gagamitin din natin yung acceleration at point A. So at point A, we can see that our x is equal to 0 and then yung h naman natin is equal to 10. And from our equation for position along the x direction, x is equal to v sub o times t, we can see that if our x here is equal to 0, our time t will also be equal to 0. So at point A, we now have these conditions. So if we substitute this to our acceleration equation, ax natin, again, that is equal to 0. And then ay naman natin, isa-substitute lang natin itong values na to dito sa napakaikling equation na to. So since our time t is equal to 0, this term here will just be equal to 0. And then ito din. And then simplifying this, we now have the value for our acceleration along the y direction at point A, which is equal to negative 7.2 meters per second squared. So, negative yung nakuha natin na value. Ibig sabihin, yung acceleration natin at point A is downward. So, that is in the negative y direction. So, now, in order to determine the force at point A, we will apply the concept of kinetics. So, first, we will draw our free body diagram and then our mass acceleration diagram. So here in our free body diagram, the forces acting on the car are the weight and then yung reaction or yung contact force natin. So we have components of our contact force along the x and then y direction. So we will just assume that this is the direction of the components of our contact force. And then for our mass acceleration diagram, ilalagay natin yung inertia vectors natin. Again, yung component ng acceleration natin along the x direction will be equal to 0. So, magiging 0 lang to. And then, yung component naman ng acceleration natin along the y direction, alam natin na that is downward yung direction niya. So, ilalagay natin dito, pababa. And then, don't forget to indicate the direction of your coordinate axis as well as the direction of your positive values. So, in this case, positive x will be to the right and then positive y naman will be pababa. So again, kayo ang bahala kung anong direction yung kukunin nyo na positive. So now, applying our equation of motion along the horizontal x direction. So we will have summation of forces along x, again positive to the right. Since our acceleration is equal to 0, so this will be equal to 0. Therefore, yung force natin along the horizontal x direction, which is yung horizontal component ng contact force natin, will also be equal to 0. And then, along the y direction, we have summation of forces along y. So again, taking positive values downward, this will be equal to MAY. So yung force natin na pababa is yung weight ng car natin. Again, since the given in the problem is the mass of the car, we will simply express our weight in terms of mass. So that will be mg. And then minus our contact force or the y component of our contact force. Since we assumed that the direction of that force is upward, yung ilalagay natin dito is negative. So that will be minus ry. And this will be equal to MAY. Isa-substitute lang natin yung mga values natin and then we will solve for our y. And now we have the value for the y component of our contact force. So that is equal to 3,132 newtons. So positive yung nakuha natin na value dito. Ibig sabihin, tama yung direction na inassume natin initially, which is upward. Ibig sabihin, yung contact force natin along the y direction is 3,132 newtons upward. Okay? So again, hindi na siya bago kasi medyo similar siya doon sa mga na-discuss natin na rectilinear motion on our previous videos. So next, let us take a look at this another example. So the 1 kilogram collar P slides on the vertical bar and has a pin that slides in the curved slot. So the vertical bar moves with constant velocity, v equal to 2 meters per second. The y-axis points upward. What are the x and y components of the total force exerted on the collar by the vertical bar and the slotted bar when x is equal to 0.25 meters? So as we can see from our diagram, as our vertical bar moves horizontally, yung pin P natin dito will also be moving along this curved path. Okay? So, given yung equation ng path natin, so that is equal to y equal to 0.2 sine pi of x. Again, pinapahanap sa atin is yung force. Okay? So, ibig sabihin, we can use force mass acceleration analysis here, like in our previous example. So, to obtain the value of our force, hanapin muna natin yung value ng acceleration natin. So, along the x direction, we have the velocity of our vertical bar. So given yan, gumagalaw daw siya horizontally with a velocity of 2 meters per second. So since this is a constant, ibig sabihin, yung acceleration natin, which is the derivative of this with respect to time, will be equal to 0. So acceleration along x, that is equal to 0 meters per second squared. So along the y direction naman, yung gagamitin natin is yung given na equation ng path natin. So along y, we have the equation of our path, y equal to 0.2 sine pi of x. And then yung gagawin natin is we will take the derivative of this function with respect to time in order to obtain our velocity along the y direction. So taking the derivative of this with respect to time, we have this equation. And then for our acceleration along the y direction, so kukunin ulit natin yung derivative nito with respect to time. So that will be equal to this function here. So kung nalilito kayo kung paano ito ikinuha, I suggest that you review your notes in calculus. So since we need to obtain the force when x is equal to 0.25, ibig sabihin, gagamitin natin yung acceleration at x equal to 0.25 meters then. So again, our acceleration along the x direction will be equal to 0. And then for the y component of our acceleration, we will simply use this equation and then isa-substitute lang natin yung mga values ng variables dito. So for dx over dt, that is our velocity along the x direction. So that will be equal to 2 meters per second. And then yung second derivative of x natin with respect to time, that is equal to our acceleration along the x direction. So ito magiging 0. Therefore, this term here will be equal to 0. So we now have the value of the y component of our acceleration. So that is equal to negative 5.58 meters per second squared. Again, the negative sign here indicates that the direction of our acceleration is along the negative y direction. So that means yung direction ng acceleration natin along the y direction is downwards. Now, we will proceed to kinetics. So again, first thing that you should do is to draw the free body diagram and the mass acceleration diagram of our particle. And then don't forget to indicate your coordinate axis as well as the direction of your positive values. So now, along the x-axis, we have summation of forces along x equal to, again, since our acceleration along the x direction is 0, so we will simply equate this equal to 0. And then along the y direction naman, so we have summation of forces along y, and then taking positive values downward, and that is equal to may. So yung forces natin pababa will be yung weight, again in terms of mass, that is equal to mg, minus the component of our contact force along the y direction. So let me just rewrite this. Bali, gagawin natin, ilalagay na lang natin is R for our contact force. Kumbaga, reaction. Okay? So, para hindi tayo malito, kasi meron tayong Fy, Fx. So, we will differentiate our contact force by using Rx for the horizontal component and then Ry naman for its vertical component. So, now we have mg minus Ry equal to may. So, solving for Ry here, isa-substitute lang natin yung mga values from our problem. So, now we have the value for the vertical component of our reaction or our contact force, and that is equal to 4.23 newtons. And yung direction naman is upwards. Tama yung initially assumed direction natin para sa kanya. So again, similar lang siya doon sa previous example natin. So hopefully hindi kayo nahirapan doon and naintindihan nyo na yung concept ng curvilinear motion using rectangular coordinates. But take note na merong mga problems involving curvilinear motion that is very difficult to solve using rectangular coordinates. So we will discuss on our next topics on how to tackle those types of problems. So ibang coordinate system naman yung gagamitin natin para doon. Okay, so that's it for this video. Thank you for watching. See you on the next one.